Hello, my name is Jesse Lewis. I am an educator and inspirational speaker from New Jersey. Today I'm going to be presenting on student outcomes for the mathematical standard 8.SP.A.3. So just going to jump right in. Here is the standard. It says to use the equation of a linear model to solve problems in the context of bivariate measurement data, interpreting the slope and intercept. And then as all the standards do, it kind of gives you an example of what they're looking for. But we're going to kind of dig in and really pull out how to get the best from your students when it comes to a standard like this one. So the focus on this standard is the interpreting of the slope and the intercept. And so when you get to this standard, it typically happens later on in the year after you've done a lot of things with linear functions, linear equations, slope. It comes right after you talked about negative and positive correlations with scatter plots. And so this standard kind of takes all of that information and now sees if students can interpret it in kind of real life situations. Look at it. Part A is, Paul has this equation and he writes this equation, and immediately you see that it's not in typical mathematical terms. So usually when students start learning about linear equations, they're using y and x. And so it's important for students to be able to take, the mathematical terminology that they know of, a linear equation is y equals mx plus b, and now take that and convert it into a real life situation. And again, that's what this standard is all about: interpreting what you know about slope, what you know about y-intercept, and putting it into a real life situation. So in this case, students have to be able to say, okay, every time I see T or temperature, it correlates to the y-axis or my y variable. And every time I see M in this case, it stands for minutes, not slope. It stands for minutes. And anytime I see minutes or time in this context, it correlates to my x value or my x axis. And that's really the crux of this standard: being able to take what you know about slope and y-intercept and slope-intercept form and now transfer it into and interpret it into a real life situation. So now when it goes in and explains what to do, it says describe the relationship here between the temperature of the substance and the time the substance has been heated. And so in this case, there's a drop-down menu. This will probably be an online test. There's a drop-down menu. Sometimes it's a text box, and students will have to write their response. So it starts off saying the temperature was initially, and then I have to choose from these options. And so again, when you're working with students, trying to get them to understand that when they see terms like initially, they have to be able to interpret that as, okay, initially means that right now time is 0, and because time is my x variable, or it's replacing my x variable, if time is 0, that means whatever time, or in this case m, is 0, then my y-intercept is my initial value. And so the correct answer for this would be 40, because that's the y-intercept you see up here in the equation. And so the temperature is going to initially be 40 because that's where time is 0. And then I have to interpret the slope. So the temperature increases by blank degrees Celsius every blank minutes it was heated. And again, students have to be able to understand that anytime I'm talking about temperature, that's going to be my y variable or my y-axis. Anytime I'm talking about time, that's going to be my x. And understanding that slope is going to be rise over run, or the change in y over the change in x. So my first value is going to be what's going to be my rise over run. I have to look at my equation and say 2 is the slope, and so I interpret that as 2 over 1. And so the temperature increases by 2 degrees Celsius every 1 minute. And again, that's the crux of this particular standard.